Did any of you install Fusion yet? Oh, go. Oh, go. It crashed it? As it should. Wait, and when are you taking EME 50?
Spring, maybe?
And who here has taken EME 50? Are you taking it right now? Okay, so you're doing Fusion, right? Okay, so you already know something. Can you guys see it? What? FEA? What do you mean by both parts? Not the rear brackets, just the front for now, and we'll do the rear later. Well, you can just watch for now. But yeah. I mean, yeah. If you can leave whenever. Okay. First I'm just gonna go over making the mold in SolidWorks. So you can just watch in the video again. But it's really simpler. It's really similar to making our, actual wing, except this time it's inverted. It's a cut instead of extrude. So really simple. But we'll just start out again importing our airfoil. Browse. Adios. Okay, so I have my airfoil here. And does anyone remember like how our molds look like? It was just a with the airfoil in it. So we're gonna do that right here. Make a sketch on this plane. Convert it. Delete the edge relation. Hold up. Okay. Does anyone know how to get our chord length for our
what?
airfoil? Close. Okay, so we make a line from the trailing edge to the leading edge, and we set up another line perpendicular to that. That's tangent to the airfoil. So, and then perpendicular and tangents. Boom. So this is our chord, and this is just a kind of reference. All right, for this one we'll do like 200 or 300 millimeters, and yeah. Next thing we're gonna do is make our stock. So our stock is just gonna be a big just a big rectangle. And the width of our tooling board is 2 inches, so we'll set it at 2 inches. So now we have our airfoil and our tooling board. Our airfoil is around 12 inches long, so for the mold, we would ideally kind of have some extra length on the edges. So let's set it to like 15 inches long. And now we can bring our airfoil in. So since it's just going to be flat, we'll set it as horizontal and put it on the put the cord on the edge of the mold. So now I have something like this, and what we're gonna do is make the lower half of the mold, so this kind of like upside down, or this concave surface. So this like kind of jank, but there's this thing called trim entities. You just like delete all this. Oh shoot. Um, Maybe not all of it. See, another way we'll do it is just make it a construction and extrude the mold itself. 4 feet. All right, and now we're just gonna cut it out. So, mm, um, so if we cut it out like this, it won't really work because we'll have, this kind of top overhang. So we want to delete that too. We can just low-key make a big square. Shoot. And yeah. So we have our airflow mold. This is what we routed on the in the ESDC, and it's where we made our test part. I don't know if any of you saw it. You guys saw it? It was hella shiny. So yeah. So now we're gonna save this and bring it over to Fusion. So what's kind of nice about SolidWorks and Fusion is you can bring parts from SolidWorks into Fusion and do your CAM there, and then you bring the CAM over to your router or like whatever tool or machine you're using. So what we'll do is File, Open, and we'll get our mold. It'll take a second. Mm. All right, so we have our mold in Fusion. It's upside down, but we can just flip it, click it, and rotate. Move. All right, now we have our mold properly orientated. Next thing we're gonna do is go to design and then go to manufacture. It's kind of nice because Fusion has like everything in one. Sort of similar to SolidWorks, but I don't know. And let's orientate our part a little better. Okay. So whenever you start a cam, you want to set up your stock first. especially your coordinate system. That's probably the most important thing. Where you have your origin is where you want the origin to be when you start routing it. Or else, let's say you have your origin in the bottom left corner in your CAD, or in your CAM, and then you zero it in the top right corner in real life, then it's just going to do everything like over here and not on the actual part. So you want to make sure and remember where you put your origin. Um, First, we'll start off by making our stock. So just go to Setup, New Setup, and we'll just choose just a router. Uh, oh my God. Okay, screw it. So there's a ton of different options to like really look through. Um, Again, you'll kind of learn this more in EME 50 if you do take it. But for now, I'll just go over it pretty briefly. So, there's different machines. We're just using like a generic router, um, which is not. Mm, oh my God. Oh my God. Sorry, guys. Okay, so we have our router loaded. I don't think that was really important, honestly. And then our work coordinate system. This is legit like the main thing. You really don't want to mess this up. So we're gonna choose our like a bottom left corner. In real life, we would zero it off this corner, and that's what we're gonna try and do here. So let's like pick this point. Um, so our positive x would be along the width, our y would be along the length, and our z is on the top. So if you did it here, your coordinates would be completely screwed if you don't zero it in the exact same spot. So it's nice to do it in the corner because when you have your router, you can just go to the edge, zero it, go to the other edge, zero it, and then zero it on the floor, and that's your kind of setup. So we have that. Next thing is our stock. Sometimes our stock isn't the exact same size as the model, so we can kind of make it maybe a little bigger. Actually, I'm just going to keep it for simplicity. But assuming it was different, you would just route out the rest of the stock. And yeah. So all right. So we have our model all set up with our coordinates, with our stock, and now we just want to route out the airflow shape. This operation is super easy compared to other types of CNC. What we're just going to do is a 3D parallel. There's a lot of different operations you can do in Fusion. 2D, facing, you can just face your surface, or 2D contour, you can just like kind of cut it out like this. 3D, of course, has that added element. And what we're doing in this one is a 3D parallel. So how we're going to route our mold is just like drag it along thingy until it gives us our airflow. So let's select our 3D parallel, select our tool, and we're just going to use a 1/2 ball end mill. There's two main types of end mills that we use. They're flat end mills and there's ball end mills. Flat surface ball has like a kind of circular bottom. Our ball end mill is kind of better for getting into these like contours, as if you think about it, if you used a flat end mill, there would be a lot of steps. So having a ball creates like a little kind of like curved surface that makes it a little more smooth to cut. So we'll choose that, and no coolant. Our spindle speed for this end mill is like 18,000, and our feed rate is, oh shoot, Mm, 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 mm. And our feed rate is like 150 inches per minute. You'll kind of get more familiar with the feeds and speeds as you do more routing. Yep, yep. Okay, so next thing is your machining boundary. It's essentially where you want to cut, and what kind of what feature you're trying to cut. So we're just going to choose our selection and just choose our kind of curved surface. We're not cutting the top because it's already flat. Actually, okay. Yep, so we're not cutting the top because it's already flat, and we just selected this inside surface. And that's it. Things like rest machining, if you had an operation before this, then it'll cut the rest of that stock it didn't get, and everything else is not really needed. Another thing is our boundaries. The tool has kind of different heights that it goes to when it machines. Our clearance height is the top, when it kind of goes up to move out of the way and then goes back down. Our retract height, kind of similar. Top height is where the top of the stock is, and bottom height is where you want the mill to cut at the bottom. Sometimes you want your bottom height to be below the stock. So for example, if you're cutting something out, you would want to go through the entire mold so you can take it out. But for this one, since we're not cutting through the entire mold, we'll just leave the bottom stock, or the bottom height, at the bottom of the stock. And our next one is passes. Again, we're kind of going in this direction, so we'll just set up our kind of pass direction. Right now it's going lengthwise, but then we'll make it go widthwise at 90 degrees. And directions, if you know like the way end mills are made, there's like a cutting side, there's conventional, and there's, what's the other type of milling? There's climb. There's climb and conventional. Each one has like a different kind of, it leaves a different surface and cuts differently. But since we're just using foam, it's fine if we go both ways. And yeah. So let's just do this for now. Oh, before we do that, let's just smooth it and optimize our feed. I really don't know what those do, but they sound nice, so I'll just click them. And yeah. So we have our simulation set up. We can see how it would look in Fusion. So yeah, it's just like this. You just stare at this for an hour. Yep. But luckily, Oddve did all of that for us, so thank God. And yeah, this one would take 30 minutes, so not as long, but that's because we're using a more rough finish. If you can kind of see on the simulation, so there's like these really big ridges left by the ball end mill. It's better than it is if it were a flat end mill, but it's still not that good. So what we can do is reduce like our step over height to make it closer and make it a much finer surface. So just go back into edit, and we will reduce our step over to like 0.08.
Yeah. So this, so the bottom point here.
Actually, yeah.
We go up and the print product can go like.
All right. So if we look again, it's a lot finer, so it's gonna be a lot smoother. There's a kind of trade-off. you can either spend a lot of time routing and then you spend less time sanding, or you spend more time routing and less time sanding. Um, I hate sanding, so just kidding. I don't hate sanding. It's just really annoying when it's foam. Um, but it's you can kind of pick your poison. You either stare at a router for another hour, or you stare at sand and mold for another hour. Um, yeah. So now it's really nice. Um, and that's how you would make the lower half of a mold. So pretty fun, but we already did this. I want you guys to practice this though, if you're interested in doing the nose cone and the front panel cam. I can quickly try and show you guys right now. I haven't done it yet, so it might be bad, but let me just open our nose cone and front panel. So this is our nose cone and our front panel. It's two separate pieces. If you've seen on our car this year, that's how we did it. And we're gonna do it again. This time it's a lot more simple than last year. This is just like a little hat, and then this is just a little panel with some curves. So we're gonna be using a positive mold this year, and let me try and I'll try and do the cam for our nose cone. All right, so it's not actually wood. Rip. I'll just remove it. Okay. Okay, never mind. We're just gonna keep it as wood. It doesn't matter. So let's make this a solid. We'll just sketch. Uh, right now I'm just splitting it because I'm kind of done. Boop, boop, boop. All right, so now we have our solid nose cone, right here. And does anyone remember the thickness of our foam? I said it like 10 minutes ago. 2 inches. Awesome, Azim. Okay, so we need to cut this up into 2-inch segments, because this right now is, I think, 8 or 9 inches. So we'll have like kind of 5 different pieces. We'll just use split again, or we'll first kind of make our split planes. And 2 inches, flip it. Okay. So we have 7 different planes to split it, and we'll split it. Boom. Select all our planes, and you cut it. And now we have a bunch of different bodies. Oh my god. Okay. Okay. So, this would be our bottom piece that we would route, and then we'd have the next piece put on top of that, and then we route our next piece, put it on top of that. I'm planning to like just give each piece to different people, and we'll just make your cam, and in the end we'll just combine all of them and then do our layup. So it's good practice, to do cam, um, and I'll just review, each one before we do it as well. So you just do each piece, just like a cake, and yeah. So I'll just start by doing the lower one since that's the biggest. Ba-bam. Oh shit. Actually. Alright. We have our thing, put it in Fusion, just like we did before. File, open. Banana 3. I'm tweaking, guys. I was in SF 12 hours ago, and now I'm back here. Take me home. Talk to him. Okay. So, we have our thingy. Let's move it up. Move. Okay. Okay. Now this one's gonna be a little different. Um, since the inside is like completely fine, we're just gonna like route the outside. Um, really simple. How we'll fixture it is we'll just screw the board into the router, um, and then just like, and then just take the screws out. So again, do our setup, new setup. Let's choose our coordinate, and then that's it. Our stock. Um, let's do like a fixed size box, maybe 18 by 18 inches, and we'll just route all that out. Looks good. So again, we'll center off this bottom left corner, and then just route everything here. So let's do our 3D. What operation do you think is best for this, Justin? Based off your EME 50 knowledge, because I don't know the answer. Okay, 2D milling. That's a good old. Mm. Ooh, does this look familiar? Because I think this is what we want. We want to do a 3D contour. So choose our 3D contour. If it doesn't work, you can always try uh, different operations. Just see what's more efficient. The way I like to think it is like you're just erasing stuff. If you want to erase like an entire sheet of paper, you wouldn't use like the back of a pencil. You use a bigger one. But if you're cutting into like, if you're trying to erase like one tiny letter, um, one tiny feature in this case, you wouldn't use the humongous eraser. You'd use the back of your pencil. So, you could face the entire piece of stock with like with a 1/8 end mill, and maybe like a different operation, or you could use a bigger end mill and do it. So, you know, it just kind of comes with experience on what tools to use and how you would do it. But yeah, so again, 18,000 and I can't read. 50. Okay. So, mm, 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 mm. Okay, I'm lucky just gonna try it. Okay, let's just run it and see how it looks. Okay, that's horrible. But it's kind of like similar to what we were looking for, where we just want to like machine the edge. Um, but it should be going all the way around. So, there's like troubleshooting with this. Um, I think I just didn't select the right boundary. Bruh. Yeah, I'm tweaking. Uh, uh, mm, boundary. Nice. Okay, that's kind of what I thought it was. So the issue there was with the tool containment. Inside boundary, if you see the kind of green line, inside the boundary means the end mill will only go on the inside. But that's not what we wanted because we want to route on the outside of that. So that's why we needed to choose outside boundary. So if we simulate this, that's too fast. So you can just kind of see how the end mill would run, making our shape. Boo. And it crashes here. That's okay. Oh shoot. Okay, now it's not cutting this. I'll figure that out. But on this side, this kind of representative of what we would be looking for. If I can angle it. So just, there's going to be ridges, but this is what we'll sand. Um, and yeah, another thing you can see is it's not actually cut out in the entire mold, just because you can still see green here. So this is what I was talking about earlier with how you need to maybe set the bottom offset a little more. Since this is a ball end mill, if you think about this, it's not cutting all the way. So we'll set like a little minus 0.1 or 0.1 inches. And now it cuts through all the way. So you'll need to do this for each of yours, just to make sure that you're cutting through the entire stock. But this, why are you not working? Okay, I'll fix that later, maybe. But yeah, this is how you do one piece of cam. And as you saw in this, we have 8 pieces. So 8 different opportunities for you guys to learn. These pieces will be a little smaller, so or less steep. So you might have to do a kind of shorter step over. To do that in Fusion, you'd go back into Edit and reduce our step down to maybe like 0.1. So then it would only go 0.1 down, do it, point one down, do it. So it's a lot more fine, which is what we want for, these kind of upper sections. But for these kind of steeper ones, it's still good if they're fine. Well, it's probably better, but it's not too bad. Because again, we're just sanding the shit out of this. So yeah. And yeah, that's how we would do our nose cone mold. Um, quick demo, I think. Do you guys have any questions? Any questions on your own project? Oh, yep. Azim. Oh, good question. So, how do we connect these different stacks, right? So this is kind of a problem we had last year. We routed all of the molds, but we just had to like manually align it, and we just used basically wood glue to put the pieces together. This year, what we're doing is we're just gonna have like two PVC pipes in each mold, and then we'll just put all of them in the pipes together so that they're all like aligned. So how do you do that? Is just like a maybe just like two half-inch PVC pipes, or no, just 1 inch. Sorry, just somewhere there. Yeah, you would route it. I'll make all the CAD and then I'll distribute it to you guys so you guys can do it. But yeah, you would just like have two pipes here, maybe in the middle, and just extrude it for each piece. So something like that. So yeah, you would have like these two holes, um, in like each piece. So you would have to route this too. But it's pretty simple because you just do that. It would be another operation. And after, we just stick two pipes in there and align it and just put wood glue. So yeah, pretty fun. Yeah, in the winter, I'll teach some of you guys how to use the router at Inventopia too. Um, just a CNC router. So yeah, it's a good start to learning CNC machining in general. Next you'd go to CNC mill and maybe a CNC lathe, but CNC router is really easy. Yeah, that's all I have. Yes.
Would you be willing to show me how to pull the full car CAD from GitHub?
The full car CAD. Yeah, so right now I think it's in a private repository. I think we're waiting for the final CAD freeze before like posting it. But
All I can see is powertrain structures and with what was shared.
yeah,
Okay, that's fine.
let me see. I'll ask Heather that, but it would. Oh wait.
And then I wanted to figure out where the mounting points are. Like, where do we see that? For the rear wing.
For the rear wing.
Element.
So yeah, that's actually what I was gonna post later today. Let me just show you for the front wing. Shit. That's another thing. When you open this like MasterCAD, I already the accumulator. I think the accumulator has like 8,000 parts or something. I forgot. It was this humongous number. But let me show you for the front wing.
I was just thinking about it, but the little tiny quarter, they're like $1.
Okay. So this was a mistake.
$1 billion times 0.3. So 1 point.
I think this is a crash. Oh, shit, wait, I got it. Yeah, okay. Click on the front wing. sketch.
Well, sorry, the other one, castle. Castle has.
Oh shit.
Maybe not
And the sketch is reference to the wing element itself, right? Not the
So the way I did it,
What did you do?
each airfoil is kind of like has like a local coordinate system, where the x-axis is the chord. I meant that. Yeah, the x-axis is the chord, and then that perpendicular one is the y. So let me show you. Oh my god. So we what is up?
It's probably AC. Yeah.
So yeah,
okay, and then what I can do is just mirror that on the element itself.
yeah, I'll be doing that. So for example, like our second element, you can kind of holy shit. So you can kind of see this is our chord, and then we set it as like our x-axis, and then we do 0.5 down and 0.5 or 0.2 away, and we'll put our hole there, and then we have another hole,
You gotta like
0.25 down, 0.5 down. So that's kind of our local coordinate system, and it's nice because when we adjust the pitch of our airfoil, this stays the same. You know, if you were to reference it off just the end plate, when you rotate the airfoil, you won't have those holes kind of aligned. So it's pretty cool, and kind of similar for the front wing. So yeah, I'll send that CAD later today. You're gonna be my slave. Yeah. Standing lead.
We need
Okay.
to make that an official thing.
Yep. But yeah, I know all of you show up to the meeting, so I want to like prioritize you guys when we manufacture our airfoils. That's a really fun experience. You shouldn't get cancer. I was like reading it in, and I was like, So I looked at the SDS, and it said it was like fine.
Now, something is actually really cancer. Like something that we avoided, something that drives
Probably like mold release. Yeah.
that one.
But the epoxy, it said just use in a well ventilated room. So that's fine. And we wear gloves. So you should be perfectly safe.
It'll be
It's
fine.
not that. It's a fucking garage. Garage doors open.
It's a garage.
How much are respirators?
They're $30 on Amazon.
Oh wait, that's like hella. What like kind of filters do you have to get to filter out this?
Oh, that's a good question. So, we want to use I think this one. So yeah, pretty sure it's this one because we want the protection against organic vapors, aka our epoxy. This is especially important when you're dremeling carbon fiber, so you don't become a coal miner. So you can get the it's actually a really good price right now. Holy dude, I might get this, uh, an extra one. But yeah, you wouldn't want to use just like those N95 masks because those don't filter out, you know, these organic vapors, and I don't think it would really filter out carbon. Yeah, it'd be like that. So yeah, that's it. That's our meeting. Do you guys have Thanksgiving plans? What's that?
Oh my.
What class are you most worried about? I don't know. I don't know what that's. This is more like a job, I think, than a class.
Just flip the undertail.
Yeah, if you guys can get that to work, that'd be like crazy. Because
Well, what we need is the full CAD for